So this is 11.1, day 2 is what it is. So you're trying to find the next 2 terms of the sequence as a warm-up and the nth term. So it does help to discuss this kind of thing with people, but it also helps to just stare at it a while yourself, because sometimes you'll figure it out. The top there is different from the bottom. That's a clue. You don't have to figure out one rule for everything. You need to figure out how the top works. You need to figure out how the bottom works. So treat those as separate problems, right? In a real sense, this is one formula, but it has 2 formulas in it. The top formula and the bottom formula. They are different patterns. Okay? So how many of you are analyzing the 137 at least? You're just looking at the 13715. Anyone looking at that? Okay. So you'll notice something about the 13715. It goes up by what? It goes up by 2 here, right? And then it goes up by what? 4. And then it goes up by what? 8. So you can probably predict what it's going to go up by the next time. 16. Right. So that kind of gives us a clue. Oh, okay, our next term is 16 more than 15. So what is our next term? 31 for the numerator, right? And the top of the next one, go ahead and figure that out. Don't shout it out, but figure it out. You're going to be going up again, right? There are conclusions we can make and facts we could write down from this, which we will. Okay? Actual stuff you can hang your hat on. Statements you can trust to help you with the next time you see this. Okay, so if it went up by 16 on the last iteration, this time it's probably going to go up by what? 32, which makes our numerator for the next fraction what? 63, right? Okay, I want to show you something real quick. What happens if you find, see those red numbers? What happens if you find the differences between those? So these are called the differences. What if we find the second differences? That means we look at how the red numbers grow. Okay, this is calculus thinking early, okay? So, what do you notice? Between 2 and 4 it grows by what? 2. Between 4 and 8 it grows by what? 4. Between 8 and 16 it grows by 8. Very interesting. Between 16 and 32 it grows by 16. What happens if you do this again? And you find the third differences? It's going to give you the same thing. This is going to happen forever. So what's going on is the growth is a certain pattern. The rate of growth for the growth is the same pattern, and the rate of the growth of the growth of the growth is the same pattern. We call this exponential growth. When somebody says, my money is growing exponentially, what they mean is, it doubled last week and it will double again. You see? It will double again. So the ratio, whether you're looking at the growths or the original amounts, or the growths of the growths of the growths of the growths, it's always double, 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 double. Okay? In calculus, we would say that the derivative of an exponential is itself. So we will get to that next year. But this is early calculus thinking. So what did I do? I found the red numbers. How did I get those? Differences. Right. Just the difference. 3 minus 1, 7 minus 4, 15 minus 7. And then I found the second differences. What were the second differences? The differences amongst the differences. Right. And we see that when the differences of the differences are the same, this is an exponential growth. So what I'm telling you is, I'm giving you a hint. This is a something to the n. This is something to the n. And then there might be like a constant or something here, okay? So see if you can figure out what goes in the blanks there. Okay, so, well, what did you notice about this exponential growth? What are these numbers in red, these numbers in green? They're all powers of what? 2. 2, right. So it's definitely a 2 to the n type pattern. And And then you have to decide, is it really 2 to the n? I don't think it's exactly 2 to the n. 2 to the n would give you 2, 4, 8. But look at the black numbers we started with. They were 1, 3, 7, 15. So how does, I'm sorry, 2 to the n gives you 2, 4, 8, 16. Here I have 1, 3, 7, 15. So what's the difference between 2 to the n and what I actually have? Yeah, there's a minus 1 here that needs to go here. That will just make sure it starts at 1 and goes 3, 7, 15 instead of 4, 8, 16. Okay, so this is a minus 1 right here. 2 to the n minus 1. How many of you had that pattern? You actually guessed that pattern. Do you have to fully guess it next time? No, you could check the differences and the differences of the differences. If they are the same, it's exponential. Good thing to know. So go ahead and record that on your paper. I'll write it down too after I answer the question. Okay, so our first takeaway here is that if the differences are growing and the differences of the differences are the same, we call these the second differences. If the second differences are the same as the first differences, the growth is b to the n. B to the n. In other words, exponential. Okay, that's the first takeaway for today. And I know it's during the warm-up, but this needs to get transferred to your notes at some point. Okay? Because it's a new truth. And I like it when you stumble across your own truths. So trying to get you to think on your own. Look at the denominator. Find the differences. Find the differences of the differences. Maybe you can write another sentence like this purple one I have. Especially if I've already figured out the bottom. Okay? You could write your own sentence. Okay, so what are my red numbers downstairs? This goes up by what? 3, and then it goes up by what? 5, and this goes up by 7. That's right. So it seems like the next growth is going to be by what? Not 4. So this is going to be going up by 9 when you go to the next term. So what's 9 more than 18? 27. Most of you probably already had the 27 here. That's not really my point. We're trying to get you to understand how this works. So next would be, of course, adding 11. I'm sure if I asked for a show of hands, everybody would say they had the 2 correct. It's getting this general term over here figured out. This is the hard part, right? So you have to have some understanding. The second differences in green are what? 2, 2, 2, 2. Did anyone figure out the denominator of the general term? Did anyone figure that out? Yeah. Raise your hand if you think you have a little formula, something here that actually works. Anyone? Okay, half the class has a formula there. Do you have n squared plus 2? Yes. Okay, so can we make a conclusion about the relationship between second differences and a quadratic expression like n squared plus 2, which, by the way, is the right answer? How could you write a sentence about this? Go ahead and write it. If the second differences are what, then what? That's what I want. I want a sentence, okay? Write it. If the second differences are what, then the pattern or the growth is what? That's what I want you to fill in, okay? Use words, use math words. N squared, what do we call that in math, right? It's a good adjective, not exponential. Any question, Jack?
No, I'm just going to say.
Oh, okay, we're not ready for the answer yet. Okay, so how might we complete the sentence? If the second differences are what, Jack?
If the second differences are constant and the growth is quadratic.
That's correct. If the second differences are constant, then the growth is quadratic, or the pattern is an n-squared pattern. That's good to know. That's really good to know. That takes a lot of the guesswork out of it next time. Just find the difference. Find the differences of the differences. If it seems to be constant now, well, you've got an n-squared pattern. Good to know. Does anyone care to postulate what a cubic growth would look like?
It would be 3, 9, 47. I can't do the others.
Do me a favor, guys. Analyze this one. These are the perfect cubes from 1 to 7. Take a moment. Find the differences. Okay? Find the second differences. Okay? See what you've learned from this. So we can write a sentence about this one now. Okay? Mathematics is the study of patterns, is what it is. So if you can find the pattern yourself, that's much healthier than me telling you. Draw your own conclusions. What are the differences here? Plus what? 7, 19, 37 is correct. 61. What's the next one? 91? Hard to see a pattern in that, isn't it? Isn't it? 127? Really? Okay, whatever. Not very helpful, is it? Did I get them all correct? Okay, let's look at the second differences.
12, 18.
Go ahead and write them out real quick. Okay, this is an interesting pattern. Yeah, 12, 18, 24, 30, and 36. Interesting. The second differences are very telling. What about the third differences? Go ahead, find the third differences. Remember, this was a cubic pattern. These are the n-cubed numbers. So don't shout it out. We're going to write our own sentences, right? We're going to draw our own conclusions and write our own sentences. Everybody participates in math. That's how we learn. What do you notice about the third differences on this problem? Plus 6, plus 6, plus 6, plus 6. What do you notice there? The third differences are all what? Constant. Finish the sentence. If the third differences of a sequence is constant, the sequence is not quadratic, right? Fill in your sentence, okay? Okay, go ahead and write your sentence. If the third differences are what? The third differences are constant, then the growth or the pattern is what? Yeah, the pattern is cubic. Yeah, the sequence is cubic. Interesting. Okay, now where this gets super challenging is when somebody tries to mess with you and gives you something like n cubed plus n squared. Okay? Where they take 1 plus 1 and 8 plus 4 and 27 plus 9 and the 64 plus 16, and then they combine them all like this. 2, 12, 36, 80. Here, figure out my pattern. Oh, man. There's a way to do it. I don't have time to teach it, but you would actually assume that it's cubic by studying the third differences. Then you would do a polynomial fit. You would find the perfect polynomial that fits these points, and then you would actually find it's n cubed plus n squared. Too much work. Don't do that. But what I would like you to do right now is create your own little pattern, okay? Create a formula and pass it off to your neighbor and see if they can figure it out. So here's what I want, okay? Let me explain the rules of the game here. You have to create a number list using a formula. So you're going to actually create the formula first. Maybe you'll go 2 to the n plus 3 and then on the bottom, 3 to the n minus 4. Go ahead and figure out the first 4 terms, and then don't show this to your neighbor, just show them the first 4 terms. See if they can figure out what pattern you're using. Okay? Don't get too carried away. I'm telling you, if you do 2 to the n plus n, they'll never figure it out. So don't do stuff like this. Make these constants, okay? Make these constants, please. 3 and -4, whatever, okay? Don't use n's more than once. 1 n on top, 1 n on bottom is plenty. All right? So create a formula, write out the first 4 terms, pass it to your neighbor, see if they can solve it. There's actually one more sentence we didn't write, and it's sort of the obvious case. So let's write one more sentence. If you have something like this, guys, 5, 11, 16, I meant to put 17 there. Quiet, please. 23, etc. If you see this, and your very first differences are common, this is automatically linear growth. So go ahead and write this sentence. This is our last sentence. If the first differences are constant, the growth is linear. The pattern is linear. What does that mean? It just means that your nth term is going to be 6n plus or minus something. Okay? 6n plus or minus something. But into the first, in this case. Okay, so does anyone care to guess what this is? This is not 6n. 6n produces 6, 12, 18, 24. I have 5, 11, 17, 23. So what is my formula here? 6n minus 1. Yeah, 6n minus 1. But I knew it was 6n because the common difference was 6, see? And so that means it's going to be, since it's constantly on the first try, that's going to be linear growth. And it's a 6n. So those are the easiest ones. Okay, but I thought we should write that sentence anyway, don't you think? To just make it all complete. Okay, some of you tried 3 to the n. Okay, I sent you an assignment, and the assignment was to do page 864, and there's a whole smattering of different styles of problems. Let me show you some of the other styles of problems that show up, okay? What I've taught you here is probably the hardest thing to understand. So the rest of this is pretty easy, and it won't take me more than 12 minutes, which is how much time I have, 10 minutes. Okay, so the first thing you need to know is what is a recursive formula. What is a recursive formula? So everybody write this down, okay? If I say this, A1 is 3, and A sub n equals A sub n minus 1 plus 5, this is not a challenging problem. I'm just going to ask you to find the next, or I'll just find the first 4 terms. Okay, find the first 4 terms and the general term. Okay, so here's what you have to understand. When I say A1 equals 3, what does that mean? That's actually, I'm giving you the first number in the series, okay? So when you see this, you need to think, oh, that's kind of like f of 1 equals 3, see? That's kind of what it means. The first value is 3. So I'm actually starting the sequence for you. So I asked you for 4 terms, but you really only need to find 3 because I gave you the first one. Okay? So you need to know what a sub 1 means. It means the first term. Okay? Second thing is you need to understand what this phrase here means. This is very important. And not everybody sees it right away, what this means. What does that mean? Well, if you turn it into an English sentence, okay, it might help you understand it. This is called the nth term, this is pronounced is. How many of you knew that equals is pronounced is? 2 people here knew that equals is pronounced is. Oh, wow. This part, what does that mean? This is pronounced plus 5. So we're going to turn this into an English sentence. The nth term is something plus 5. So what does it mean? A sub n minus 1. What does that mean? So this would be like A100 would be A99 plus 5. A15 would be A14 plus 5. So what is this thing? This is the previous term, see? So this is the nth term, and this is the term right before it. That's what it means. So the nth term is the previous term plus 5. The nth term is the previous term plus 5. Previous plus 5 is what it means. Okay? This is very easy then. Let's go ahead and fill in the sequence. The second number is the previous number plus 5. Fill it in. Go ahead. The second number is the previous number plus 5. So what goes here? Yes. The third number is the previous number plus 5. What's next? 13. The next number is the previous number plus 5. What's that? Okay, let's check the differences. These are going up, obviously, by 5s. What kind of growth is that? Linear growth. Specifically, 5n linear growth. 5n linear growth. 5n gives us 5, 10, 15, 20, 25, 30, 35, 40. So this seems like it's off by 2. Should I use 5n plus 3 or 5n minus 2? Like, what should I try here? I think I need a 5n minus 2 here. This is my answer, okay? It's 5n minus 2 because all of these numbers are exactly 2 less than their respective multiple of 5. So 5 times 3, take away 2. 5 times 4, take away 2. This is called a recursive rule in yellow. It tells us how to get the next number. This is called a general term in green. This tells us how to get any number. So if you want to find the 99th number, there's 2 ways to do it. Find the 98th number in F5, or just plug in 99. See? Which do you like better, green or yellow? Most people like the green better because they can find any term they want. But the yellow has purpose too. It tells us how to get the next number. Right? Okay? Now in the warm-up I gave you a problem that looked like this. Okay? And I asked you to write the first few terms, but I had not given you this part at all. I didn't give you that. What does that thing mean? So let's talk about that now. Quiet, please. Thank you. So this is the Greek letter sigma. Okay, in Greek, if you see a sigma, you're supposed to pronounce it like an S. So if you see a word that starts with this letter in Greek, I don't know any Greek, but if that's the first letter of a Greek word, S and then alpha, it would be pronounced sa. Sa. Just like in English, S-A, sigma alpha, okay? So what mathematicians did was they wanted to find a way for you to add up the terms of a series. Okay, so this is the same thing I gave you at the beginning of class. 1/3, 3/6, 7/15, I think it was. No, it's 7/11. And then it was 15/18. Remember this? I gave you this at the beginning. The mathematicians want us to be able to add these together. okay? And so on. So what they did was they said, listen, we need something that means sum. So like, well, sum starts with S. We could use a big fat S right here. But they said, nah, let's get it from a different language. So they stole it from Greek. So capital sigma means sum. That's why they chose it. So now you know why delta y means y2 minus y1. Delta means difference. Duh. Duh. Okay? Delta has always meant difference. It's a command. And sigma has always meant sum. It's a command. It means to add. Take out the commas and put in plus signs. This is now called a series, by the way. And this is the expanded form of the series. Okay, now, how many terms does it want me to do? That's what the 1 and the 5 means. Okay, so I actually stopped one term shy of my answer here. See how it says 1 at the bottom and 5 at the top? That means I was supposed to plug in 1, 2, 3, 4, and 5, but you can see I never actually plugged in 5. So I need one more term here. I need to plug in 5. That gives me 27 here, 31 here. So this is the expanded form of the series. If you really want to, you can get your calculator out and add these up. But I was just going to let you leave it like this. Okay, so I think I got all those values right there. Okay, so on the homework, you will have to do this backwards a little bit. But I'll record a couple of examples if you need and post it on YouTube. How to do this backwards to create the sigma. Okay, so if you need to work backwards, let's say you have a series that looks like this, and it says write in sigma form, write in sigma notation, then you would go ahead and try to figure out the pattern in the numbers. So let's say that you're given 1 over 2, so your numerators are 1, 3, 5, 7, and we're going to be adding here, not commas, so we're going to use pluses like this. And the bottom, let's say, is 2, 4, 8, 16. Let's do a couple more. Let's do 9 over 32, and so on. And let's go ahead and stop when we get to, 15 over 256. So to basically figure this out, you need to know quite a few things. We're going to try and create a sigma. Now you can kind of figure out how many terms there are because it goes 1, 3, 5, 7, 9. That's 5 terms. And we're missing the 11th term, the term with 11 on top, the term with 13 on top, and then the term with the 15 is the last term. So there are actually 8 terms here, so I meant to put an 8 here at the top. Sorry, it looked like an infinity there. I think I wrote an infinity. Sorry. Anyway, yeah, so 8 terms altogether, and then we're going to try to construct our pattern. So we studied this today. This is going up by 2's consistently. So that makes it a 2n pattern, specifically 2n minus 1. And then the bottom is going up by 2's. 2, 4, 8, 16, and the second differences are also 2, 4, 8, and so forth. So that's an exponential, specifically base 2 exponential. So it's 2 to the n. Actually, it's exactly 2 to the n. Okay, so we just created our sigma. Why did I start at 1 and end at 8? Well, it's because there's 8 terms. And then just to check your work, you can try and expand your sigma a little bit. So you can go 2 times 1 minus 1 over 2 to the 1. 2 times 2 minus 1 over 2 to the 2. 2 times 3 minus 1 over 2 to the 3. And just verify that these first 3 terms are actually working for you. It's basically 1 over 2, that looks right. 3 over 4, that looks right. 5 over 8, that looks right. And then also, don't forget to check the last term. So the last term, I'm going to erase, but the last term would be 2 to the 8th, or sorry, 2 times 8 minus 1 over 2 to the 8th.
which gives us 15 over 256, and that works too, doesn't it? So this is how you know your sigma's written correctly.